Understanding Mechanical Vibration, a simple guide. Hello, everyone. Welcome back to our channel, where we make learning English easy and fun. Today, we're diving into a fascinating topic: mechanical vibration. This might sound complex, but don't worry. We're going to break it down together, step by step. So, whether you're a student, an engineer, or just curious, this video is for you. Let's get started and demystify mechanical vibration. Mechanical vibration refers to the oscillatory motion of an object or a mechanical system. Imagine a pendulum swinging back and forth or a guitar string vibrating when plucked. These movements happen because of the object's attempt to return to its original position after being disturbed or moved from a state of rest. The key concepts here are oscillation, which means movement back and forth in a regular rhythm, and disturbance, which is any force that causes the initial movement. You might wonder why we should care about mechanical vibration. Well, it's incredibly important in the design and operation of various machines and structures. For example, engineers study vibrations to ensure that bridges are safe from the effects of wind or traffic. In electronics, vibration can affect the performance and longevity of components. By understanding and controlling vibration, we can improve safety, efficiency, and durability in many aspects of engineering and design. Mechanical vibrations can be classified mainly into two types: free vibration and forced vibration. Free vibration occurs when a system vibrates at its natural frequency without the influence of external forces after being initially disturbed. Imagine hitting a drum. The sound you hear is a result of the drum's free vibration. Forced vibration, on the other hand, happens when an external force continuously drives the system. Think of pushing a child on a swing. The swing's movement is a forced vibration because it's being externally driven by your pushes. To study mechanical vibrations, scientists and engineers use various measurements, like amplitude, frequency, and damping. Amplitude is the maximum distance moved by the vibrating object from its rest position. It's like how high the swing goes. Frequency refers to how many times the object vibrates in a second, measured in Hertz, Hz. Damping is the process by which the vibration gradually reduces over time due to energy loss in the system, similar to how a swing slowly comes to a stop. And that's a wrap on our exploration of mechanical vibration. We've learned that it's an oscillatory motion caused by a disturbance, significant in various fields for ensuring the optimal performance and safety of structures and devices. Whether it's a bridge, a musical instrument, or a piece of machinery, understanding vibration is key. We hope this video has illuminated this intriguing subject for you. Thanks for watching, and stay curious.